name is Dr. Esther Trufan, and in this video, I'm going to talk about percent composition. By definition, this is the percent by mass of each component in a compound or each component in a mixture. So part of a whole. This applies to elements in compounds or substances in mixtures in the context of chemistry. The formula for calculating percent composition is mass of a part, and this could be the element or the substance, divided by mass of whole, and this could be the compound or the mixture. And because we're looking for percentage, we need to multiply it by 100%. This needs to be calculated for each of the parts of the whole that we're looking at. A couple types of problems that could come up in the context of percent composition are these. We have a mixture of salt and sand. So we have two compounds in a mixture, and we need to calculate the percent composition of the mixture. That means that we need to determine the percent salt and the percent sand in our sand and salt mixture. To do this, the first thing we have to do is determine the combined mass of our ingredients, or the mass of the whole. So for that, we say mass total, or mass of whole, is 4.72 grams of salt plus 12.32 grams of sand. And the combination of these two, 17.04 grams, is the mass of the mixture. To calculate the percent salt, we're going to take the mass of the salt, 4.72 grams of salt, and we divide it by the mass of the whole, which in this case is 17.04 grams total. And just like before, to determine a percentage, we multiply by 100%. In this case, our answer will be 27.7% salt. To calculate the percent sand, we're going to apply the same approach. The only thing that we will do differently is, instead of the mass of the salt, we will be using the mass of the sand. We have 12.32 grams of sand. We divide this by the 17.04 grams total. Then we multiply by the 100% to get the percentage. And this is how we get 72.3% sand. In this mixture, if we add up the percentage of salt and sand, we will have 100%. Which means that we accounted for all the components in our mixture and there is nothing missing. Another type of problem that could potentially work with percent composition also connects to this ratio between the part and the whole. One of the most common gas mixtures is air. It contains nitrogen, oxygen, and some other gases in small proportions, including carbon dioxide. But most of the time when we do reactions with air, we typically utilize the oxygen as its oxidizing component, and we usually use that to burn fuels. When gasoline reacts with the air that is brought in, then the reaction will occur between your fuel or hydrocarbon and the oxygen from the air. So most of the time, we don't care as much about nitrogen and some of the small components, but we do care about oxygen. Can we determine, simply by knowing how much air is drawn in, how much oxygen is available to us for the reaction? The answer is yes. And it all comes down to understanding our percent composition problems. Here we have 6.50 grams of air, of which 21% is oxygen. So this tells us that if we have 100 grams of air, or 100% of air, then in that 100%, 21% is going to be oxygen. So if we start with what the problem provides, 6.50 grams of air, and then we say in every 100 grams of air, we have 21 grams of oxygen, because this is the 21%. Then what we have is the grams of air cancel, and we will be left with 1.37 grams of oxygen. That means this is what we have available to burn something that is around this air sample.